And that wonderful message again, the following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 2 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. Okay, so now, once again, we're going to switch over to this other screen. So, can everybody see a white word screen in front of them with nothing on it? Somebody will say yes.
Yes.
Thank you very much. Okay, so now the instructions say find each function value if possible. Do not use a calculator. Okay, so our first one is this. It says f of x equals the square root of 3x plus 1. And we are to find f of 8 and then f of -2. All right? So f of 8 would be the square root of 3 times 8 plus 1, which is the square root of 24 plus 1, which is the square root of 25, which is 5. So f of 8 equals 5. If we were to graph this function, it would contain the point whose coordinates are 8, 5. Any questions about this example? All right, f of -2 is the square root of 3 times -2 plus 1, which is the square root of -6 plus 1, which is the square root of -5, which is not real. Okay, any questions there? Next example. Let's see here. I do. Okay. All right. We have, let's see here, h of t equals the square root of t squared plus t minus 3. And we are to find h of -4 and h of -1. All right. So h of -4 would be the square root of -4, the quantity squared. Notice the negative is part of the base. It's included, plus -4 minus 3, which would be the square root of, let's see, -4, the quantity squared is 16, plus -4 minus 3, which would be the square root of 16. Oh, let's see, 16 plus -4 would be what? 12 minus 3. So the square root of 9, so 3. So h of -4 equals 3. Okay. H of -1, we have the square root of -1, the quantity squared, plus -1 minus 3, which is -1, the quantity squared. -1 times -1 is 1. So 1 plus -1 minus 3, those would cancel. So we have the square root of -3, which is not real. Okay. Next, it says to use a calculator to find each function value. So let's take a look at an example. F of x, oops, that's outside the, well, f of x equals the square root of x squared plus 1. And we are to find f of 4 and f of 2.35. F of 4 is the square root of 4 squared plus 1, which is the square root of 16 plus 1, which is the square root of 17. So now on the calculator, second square root 17, close it up, and it says round to the nearest 10,000th. Let's see. If I have 72.348791, this is tenths, hundredths, thousandths, 10,000. So 4 decimal places out would be the 10,000th place, okay? But in fact, this is what I get. I get 4.123105626. So we're going to go over 4 places. The 5th place would round down. So the square root of 17 is approximately 4.1231. Any question there? All right. F of 2.35 is going to be the square root of 2.35 squared plus 1. And let's see, if I take 2.35 squared plus 1, I get 6.5225. That's the entire radicand. But now if I take the square root of that, so let's see, second square root of 6.5225, I get 2.55391. So the 9 is the 4th decimal place, the 1 would round down. So 2.5539 would be the answer to the nearest 10,000th. Okay? Any questions there? All right. Next, we're going to simplify some cube roots. Now, all those rules I kept pounding into your head, you can't do this, you can't do that, had to do with even roots. With an odd root, like a cube root, you can take an odd root of a negative number. You can get a negative answer when you take an odd root. Okay? What's the cube root of 1? Well, it's just 1 because 1 times 1 times 1 equals 1. So the cube root of 1 is 1. What's the cube root of 8? We did this before. The cube root of 8 is 2 because 2 times 2 times 2, which is 2 cubed, equals 8. Okay. What about the cube root of negative 125? Well, let's see. What times itself is negative 125? How about negative 5? In fact, let's see here. It didn't say whether to use a calculator or not, but let's put that into our calculator. So we're going to clear our screen. We're going to put in a 3. Remember, you have to put the index in first. Then we're going to go, let's see, 3, second, the little caret key. So now I've got 3x root of. I put in negative, not the minus sign along the side, but the negative sign down at the bottom, negative 125. And I get, let's see, negative 125, and I get negative 5. All right. Any questions on that? How about this one? Let's see here. The cube root of 8 over 27. Well, what's the cube root of 8? What times itself is 8? And that is a 2. What's the cube root of 27? What times itself is 27? And that's a 3. So the cube root of 8 over 27 is 2/3 because 2/3 cubed is 8 over 27. This is kind of going back to some of those rules back in chapter 5. All right. What's the cube root of 1,000? 10, because 10 times 10 times 10 is 10 cubed is 1,000. How about this one? Let's see here. Where did my mouse go? There it is. The cube root of negative 512x cubed. Well, I can't use my calculator to get the cube root of x cubed, but I can use it to get the cube root of negative 512. So let's see here. I'm going to go 3 second x root of negative 512. And that's negative 8. And the cube root of x cubed is x. Now, I didn't say anything about were the variables unrestricted or whatever. It doesn't matter, because even if x is a negative number, because we're taking an odd root, there's no restriction on it. Okay. Okay, let's see here. Let's do these problems on a calculator. It says the fourth root of 81. Actually, I lied. It says, if possible, without using a calculator. It's the ones down below it. My bad. Let's see if we can do this without a calculator. The fourth root of 81. Well, what's 1 times 1 times 1 times 1? That's 1. So it can't be 1. 2 times 2 is 4, times 2 is 8, times 2 is 16. It's got to be bigger than 2. 3 times 3 is 9, times 3 is 27, times 3 is 81. So going the other direction, we'd get 3, okay? Since 3 to the fourth is 81, the fourth root of 81 is 3. Any questions there? All right. How about, let's see. We'll add some more pages here. And come back here. There we go. All right. Negative the fourth root of 625. Well, so we're going to do the radicand first. What times itself times itself times itself is 625? Well, it's going to be 5. Okay, I'll just tell you. But what about this negative sign here? It's going to travel over there. So our final answer is going to be negative. And then somebody's going to say, wait, hold it. You said you couldn't take an even root of a negative number. I didn't. I took an even root of 625, but outside of that was that negative sign. Okay, it was not included inside. If I said take the fourth root of negative 625, that would be not real. Okay, but the negative sign was outside. So that's different. Okay, how about this? Simplify each radical expression. Assume all variables are unrestricted. Okay, be careful. The fifth root of 32, a to the fifth power. The fifth root of 32 is 2, because 2 times 2 times 2 times 2 times 2 is 32. The fifth root of a to the fifth is a. Do I need absolute value bars there? No, because I'm taking an odd root. So it doesn't matter. A can be positive or negative when it's an odd root that we're doing. How about this one? The fourth root of 81, a to the fourth. Okay. The fourth root of 81 is 3. The fourth root of a to the fourth is a. But we're taking an even root, so I need that protection. Okay? So it's all about the index. If the index is odd, no problem. If the index is even, be careful. How about the eighth root of t to the eighth power? That would be t, but we're taking an even root. The variable is unrestricted. Okay. How about this one? This one's kind of a weird one. The fourth root of x minus 7, the quantity to the eighth power. That's going to be x minus 7 squared. Do I need absolute value bars there? No, because since we're squaring it, it can't be negative, the result. Okay, we're going to do some more graphs. Give me just a minute here. All right. This says complete the table and then graph the function. All right. So f of x equals the cube root of x minus 3. -8, -1, 0, 1, and 8. So once again, the author provided inputs or x values. Notice a couple of things. First of all, the -3 in the function is outside of the radical. So we're going to take x, put it into the cube root, take the cube root, and then subtract 3. So if we're taking cube roots, doesn't it seem like the best choices of x would be perfect cubes, which is what they've got? -8 is -2 cubed, -1 is -1 cubed, 0 is 0 cubed, etc. Okay, so f of -8 equals the cube root of -8 minus 3. The cube root of -8 is -2. -2 minus 3 is -5. F of -1 is the cube root of -1 minus 3. The cube root of -1 is -1, and -1 minus 3 is -4. F of 0 is the cube root of 0 minus 3, which is 0 minus 3, which is -3. If I'm going too fast, please let me know. I'll slow down. F of 1 is the cube root of 1 minus 3, which is 1 minus 3, which is -2. And f of 8 is the cube root of 8 minus 3, which is 2 minus 3, or -1. So when x is -8, y is -5. So that's what right there. -8, -5. When x is -1, y is -4. When x is 0, y is -3. When x is 1, y is -2. And when x is 8, y is -1. So we get a picture that looks like this. Let's see if I can graph this thing. Well, I almost made it. All right, looks kind of like that. It's a cube root function. Let's see here. What's the domain? Well, this thing continues on and continues on, so that's going to be what? All real numbers. What's the range? Well, as this thing is going to the right, it's also going up, and as it's going to the left, it's going down. So the domain and range are going to be all real numbers. Any questions there? Okay. Let's see here. Let's take a look at these are some lookalikes. Okay, so we're not going to graph this, but I'm just going to use this screen. 4. So what's the square root of 64? Anybody? Nobody wants to play? Okay. 8. What's the cube root of 64? Is it 8? No, it's 4. 4 times 4 is 16 times 4 is 64. What's the square root of negative 64? Not real. What's the cube root of negative 64? Ah, negative 4. So notice we can take an even root of a positive number and get a positive answer. We can't take an even root of a negative number. We can take an odd root of a positive number. We can take an odd root of a negative number, and we can get an answer that's positive or negative when we're taking cube roots or just odd roots in general. So it's the even roots we got to be careful of. All right. Any questions before we go? Anything for the good of the order? All righty. Then I shall stop the recording. And so tonight you're going to do section 9.1, part 1 and part 2. Can't talk. All right. Have a great rest of the day. Bye now.